You know, one thing that I think people take for granted is they take certain phenomena for granted, that they say, oh, why is the ocean blue? Oh, why is the sky blue? When I was a kid, the answers I got were, the ocean is blue because it reflects the sky, and the sky is blue because it reflects the ocean. And I said, this is not satisfying. It's also not true. The sky is blue because when sunlight comes through the atmosphere, it gets scattered in all directions. But which light gets scattered more easily? The bluer, shorter wavelength light or the redder, longer wavelength light? The answer is the blue light, which is why when you look at all directions in the sky, it appears blue because the blue light scatters away and gets reflected. And so in every direction you look, there's more blue light than any other color. And that's why sunsets look red, because the blue light gets scattered away, but the red light comes straight through. Then you say, why is the ocean blue? Completely different explanation. It's because water absorbs all of these different colors except blue. Blue is the most penetrating through water. So it has to do with the properties of light and matter, that in the air, blue light gets scattered away. In the ocean, the blue light is the last to get absorbed away. The most common misconception that I encounter is people have heard a lot about the Big Bang, but they don't know that it's not an actual explosion. The Big Bang says if you take everything that's in the universe today, it's not like some bomb went off and things went flying. It's that space itself has expanded over time. The whole universe, everything in it, I imagine like a ball of dough with raisins in it. If you want to bake bread, what do you have to do? You have to leaven the bread. So today, the dough has expanded a lot since the early stages, and the raisins are galaxies like us. So if you can only see the raisins and you cannot see the dough, all the raisins are moving apart from each other and are very far apart. What makes the Canary Islands such a special place is a combination of conditions that are very rare in the world, but are found in a few places. The summit of Mauna Kea in Hawaii, the Chilean Andes at the top of the mountain range there, and on the summit of La Palma here in the Canaries. It is close to the equator. It is a high mountain peak. It is very dry, still air. The temperature conditions are consistent and a great site for building observatories. That's where you want to go. I think La Palma, the summit of La Palma, is one of the top 3 locations in the world for astronomy. It's just a natural resource that we have. So if you live on the north side of Tenerife and you're like, why do I have to keep my lights so dark? It's to protect the skies of La Palma. It is a dark sky reserve with all of those wonderful conditions that astronomers crave, right? This is one of the key things, is science is a completely global endeavor. If you take Hawaii, Mauna Kea, and La Palma, they are almost on completely opposite sides of the Earth. This is an amazing opportunity. If you build telescopes on Mauna Kea and telescopes on La Palma, they're separated by 12,000 kilometers. You can look at the same object and get resolution that's as good as the distance between your telescopes. We have a trick called very long baseline interferometry. If you saw that first image of a black hole that was taken with the Event Horizon telescope, these would be great locations to build telescope dishes that contribute to that. If you saw the Event Horizon telescope image of our first black hole and our second black hole, the one at the center of the Milky Way, it's amazing that we can actually see an event horizon. The one at the center of the Milky Way, it changes shape every few minutes because the light and the matter going around it gets swallowed and absorbs and changes every few minutes. We could actually build a movie watching the event horizon evolve over time with telescopes on Mauna Kea and La Palma at the same time. When you build these big flagship ground-based telescopes like GTC Or, like TMT will be for the next generation of telescopes, you can suddenly say, well, hey, we don't need to use JWST for everything. JWST can find these candidates and we can follow up with the ground. So it means you get to do more science. It's like instead of just having a hammer, you have a hammer and a screwdriver and a wrench, and you can fix more things and you can learn more things and you can understand the universe better.